Hello, fourth grade scientists. Today we're going to build an electric circuit. So the first thing we're going to do is you're going to need a piece of paper and a pencil. And I want you to watch the directions on the next slide so that you can learn how to do this. And then you're going to press pause and actually draw what you think is a circuit that will connect the battery and light bulb together and will light the light bulb. But watch these directions first. Hi, fourth grade scientists. Today we're going to build a circuit, and these are the materials we're going to start with. Here you'll see we have a light bulb and a battery. It's in a little plastic case with some metal on it. This actually isn't a plastic case, and these parts are metal. And then I have two wires here. When I actually build the circuit, I'm also going to use electrical tape to tape the parts together. So the first thing I want you to do is after I'm done with this video, you're going to pause and get a piece of paper, and you're going to draw a diagram of how you think you would put these materials together to complete a closed circuit, a circuit where the electrons can move through all the parts, and we can get the stored electricity out of this battery, and we can somehow move it over here to light this light bulb. So you're going to draw a picture, and I want you to do a real scientific diagram. So I want you to label the battery, label the light bulbs, label the wires, show in your drawing where they will be connected. And you have on the screen, you saw how I drew these things. It doesn't have to look exactly like those. Like when I drew my diagram, I made the battery look more like this. I draw a light bulb this way, but you can draw your own version of a light bulb symbol. I just make the wires as lines. And then somehow you're going to draw your diagram so that these wires are connecting the battery to the light bulb in a specific way where the energy moves out of the battery and over to the light bulb, and you want to make a complete circuit. Okay, so take a minute and draw that diagram. All right, so now is when you should press pause. Once you finish your diagram, you should press play again so we can test these out. Okay, so now you've pressed play. That means your diagram is finished. So I'm going to go on to the next slide, and we're going to skipped one, and we're going to test these out. So here's the first one. I've been teaching this for a while, and this is a diagram a lot of kids come up with as a first try. Okay, so now we're going to test out some of your ideas. So some of you may have drawn a really simple diagram, a battery with a wire connecting the light bulb, and thought, okay, well, if I connect these two together, the electricity that's stored in the battery will come out and flow over to the light bulb. And so here I've tried this. I took the battery, I taped the wire to the metal end of the battery. Here's my wire, and then I taped it over here to this light bulb, and you can see the light bulb is not lighting. And the reason it's not lighting is because this is not a complete circuit. Okay, so now if we were in class and that happened, I would say, don't give up. I know you can do this. And I would say, how else could you change the wires, change where they're connected to come up with another idea of how this works? So another thing that kids sometimes come up with is this diagram. Okay, in the second video, I came up with another diagram that I remember fourth graders making when we did this lesson. And so I put the battery here, and I put the light bulb here, and then I took the two wires and I connected them to one end of the battery, and I made one wire go to this light bulb and one go to this light bulb. And so you can see here is how I set this up to look like my diagram, and you can see the light bulb is not lighting. So even though this time I did make what kind of looks like a circle, for some reason the electricity is not flowing, the electrons are not moving, and so there must be some other way to do this. And so what I would tell fourth graders to do is, if you made this diagram, think again, what could I change about this diagram that would try something different or something new to see if it would work? And we would just keep trying, and no one would give up. This one's not working, so we have to try something else. So start thinking, what else could we try? Okay, so now we're going to try again because we won't give up. And so we're going to come up with another idea. And so here's the third video. Our third attempt. Okay, For our third try, this is another diagram that I remember a lot of kids would draw. And so you can see this is looking like a circle, like a circuit. The battery is here, but this time I attached a wire to each side of the battery. And then I was hoping that would move the electricity over to this light bulb and make the light bulb light. So now I set up my model to look like my diagram. You can see I have wire attached here and here, and then I brought it to the light bulb, but the light bulb still isn't working. So now I would tell my students to think, what else could I change? So think about that. What else could I change about this diagram that would try something different and see if we could get that electricity moving? Okay, so when you look at the different combinations we've tried, there's still one that we haven't tried yet. So let's see if this one might be the one that works. Okay, so let's try again. I changed one of the wires. So what I did was I took our last two tries and I looked at the different places where I could connect the wires, and I thought, okay, well, what is one more option? So you can see in this example, again, but I attached one, then I attached the other side to the battery this way. So here is my setup. You can see I've taped the wire to both ends of my battery. I have this one connected. So now I'm going to take this and connect it, and ta-da, it works. The light bulb lights. So what's different about this diagram or this model compared to the other ones? Well, what is happening is the electrons are able to flow through a complete enclosed circuit. The electrons come out, or the electricity flows out of the negative side of the battery. Then it travels to the, to stay on. Okay, so it goes out the negative side of the battery. The electricity goes through this wire to the metal here on this light bulb holder. It travels to the light bulb, lights the light bulb, but then it can keep flowing, and so it moves back through the wire, back to the battery, goes to the battery, and it completes a closed circuit. Now, if I take this away and create a gap, now I have an open circuit. And if I touch it again, I have a closed circuit. And this is actually how you turn on the lights in your house. You turn them on and off by opening the circuit and closing the circuit. So when you go to a light switch and you turn off the light inside your wall, it just separates and turns off the light. Then when you turn on the light, it's a really small gap, but even as, look how close I am. And I'm still not turning it on. And then when I touch it, it turns it on. And that's what happens when you turn the light switch on. Now, you should never, ever, 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 ever touch the electricity inside the walls of your house. The voltage of that is much higher. You would be electrocuted. It's very dangerous. We're able to do this with a battery because it's so much lower voltage that it can't hurt me. And so that's why I'm able to touch and demonstrate with this kind of electricity. All right, so there you have it. That's how you make a closed circuit. Some really important things to notice. In order for that light bulb to light, there can be no gaps at all. Everything has to be touching. So right now, something must not be touching. Something came loose. Everything has to be touching. You have to connect the metal parts of the wire to the metal parts of the battery, to the metal parts of the light bulb in order for it to work. So just some important things about your model. In this model, you can see what's happening is the electricity is coming out the negative side of the battery, going through the wire to the light bulb, lights the light bulb, comes back around and keeps going around in a circle, which is why we call it a circuit. It's a complete pathway for the electricity to flow. All right, so exciting. I hope you guys figured out how that works. Now, what I want you to do is to take the diagram that you made to start with. You're going to press pause again, and this time I want you to draw the picture of the diagram that really works. Now, if your prediction was correct, your diagram might look the same. If your prediction was incorrect, that's okay. Your diagram will definitely look different. Once you draw it, I want you to draw arrows showing how the light bulb lights. Now, once you finish this diagram, you can press pause. Press pause while you draw your diagram. Then when you finish the diagram, press play, and I will bring you to the next screen where you can see my diagram and you can check your work. All right, so press pause and draw your diagram now. All right, so now you finished your new diagram of a working, complete, closed circuit. And it probably looks something like this. A closed circuit is the only way the electrical current can move and light the light bulb. When you drew the diagram again and drew arrows, you can show how it goes out the negative side of a battery. There's my arrow. Goes over to this metal part of the light bulb. You can see I drew my light bulb lighting. Then the electricity keeps moving. Those electrons have to keep moving, and it travels through this wire back to the positive side, and that keeps going on and on. As long as everything is touching, the electricity will keep flowing through the battery and through the light bulb and will light the light bulb. Now, here are some different circuit diagrams that may or may not work. Predict which of these circuits will light the light bulb. So in diagram 1, I have a battery with a wire and a light bulb. So right now, you can say out loud, you can write it down on your paper if you want, you can tell somebody, do you predict this one will work? In diagram 2, again, I only used one wire, but this time I laid the light bulb, and this part of the light bulb is metal, and I connected the wire from the light bulb to the battery this way. Either write down or tell someone out loud, do you think this will work? And for diagram 3, all I did was flip the battery over. So the positive side is now down here and the negative side is up here. Again, I connected the wire to the metal part of the battery and the metal part of the light bulb. Do you think this one will work? All right, once you make your prediction, we're going to go on and we're going to test this out.
Okay, so if you look at your diagram, the first battery shows a battery, a wire, and a light bulb, like this. And you can clearly see that the battery will not light the light bulb this way. So what's wrong? What are we missing? Why is this not working? In the second example, we have the wire on the negative side, so I'm going to put it on the bottom. Then I'm going to put this on the top and attach the light bulb this way. And you can see that this does work. The light bulb is lighting. So now let's look at that picture. Why does this circuit work? In the third example, we have the positive side touching the wire. And then we have the wire at the negative side. And again, we have the light bulb like this. And once again, you can see that this circuit is working. The light bulb is lit. So let's talk about why this light bulb also lights.
All right, so now let's take a look at those diagrams again. And I'm curious, I would love to know how many of you knew this. So I'm guessing most of you knew this one wasn't going to work. And so right now I would say, what could we change about this first one to make it work? So think about that for a minute. What could we do differently to make this light bulb light? Because this is the one that didn't work. Now, if I was able to call on you, I'm sure one of you guys would tell me that we need another wire. And if we took that other wire and we connected it to this side of the battery, then our light bulb would light. And if you were thinking that, you are right. That is exactly what we'd have to do. We'd have to connect a wire from the light bulb, and we'd have to bring it down here to this end of the battery. And then that would be a complete closed circuit, and the light bulb would light. Now, these two did work. And a lot of times that's really surprising because we don't have two wires. The really important thing about these two diagrams and the reason they work is because this base is metal. And so the electricity is able in this one to come out the negative side of the battery, travel through the wire to the light bulb, light the light bulb, and it still has a complete path. Now, if something were not touching, the path would be open and the light bulb would not light. If there wasn't metal conducting or moving the electricity through the wire back to the battery, this wouldn't work. But everything is touching and this works. Same thing here. This one, the electricity actually moves through the light bulb first. So it goes up here, goes through the wire and back to the positive side. But again, it's a complete circuit. As long as everything is touching, all these pieces are metal and the electricity can move, the light bulb will light. So that's kind of fun, right? So now I have another one. Here's the fourth diagram. Make a prediction. Do you think this one will work? So if I take a light bulb and two wires with the battery, do you think this one will work? And then we can try it out.
Okay, So now for the fourth example, we're going to touch the wires to the negative and positive side of the battery. And then we have to just get it just right and touch the light bulb. And the light bulb should light. There it is. It's hard to maintain the connection, but you can see that it is completing the circuit, and we do have a lit light bulb.
All right, now on this one, I'm guessing most of you predicted this would work. This actually is the exact circuit that you've drawn a diagram of. And so the electricity comes out the negative side of the battery, goes to the light bulb, lights the light bulb, and is able to have a path back to the battery. And so we have a complete closed circuit. Every part is touching, and the light bulb will light. All right, last challenge. Here is a new diagram. Do you think this one will light? For this one, I'm trying to use one battery, one wire, and 2 light bulbs. So make your prediction. Do you think these light bulbs will light? Do you think one will light? Do you think both will light? Do you think none will light? All right, now that you have your prediction, let's test it out.
Okay, so now we're going to try the fourth one. The fourth one shows the battery with a wire attached to the bottom, and it has 2 light bulbs. And both light bulbs have to touch the positive end of the battery. And then, it's really tricky to get this to work, but you get it on there, and then you get the wire to touch the metal of both of them. And this actually should be a complete circuit. So we're going to get this on here. And you can see both light bulbs are lit because this is a complete circuit. The electricity is able to flow from the negative to the positive and back through the battery again. And we do have a complete circuit.
All right, so now if we look at that diagram again, you can see this worked. And the reason it works is because the electricity flows out the negative side of the battery, travels through this wire, goes into the metal part of this light bulb, travels through the light bulb to this side, and then goes back in again, and we have a complete circuit. Now, if there was a space in between these light bulbs, would it work? One of the light bulbs would light. If you were thinking that, you are right. So if I drew this again and I drew a space in between where this one wasn't touching this one, this light bulb would light, but this would not be part of the circuit. It wouldn't light. You actually have to have the wire touching and the metal touching in order for this to be a complete circuit and to work. All right, I hope you enjoyed these different circuits. Important things to remember. In order for electricity to work, there must be a complete circuit. Another way to say this is to say it is a closed circuit, like an unbroken circle with no gaps. Number 2, the wires must be touching the metal parts of the light bulb and the battery holder in order for the electricity to flow through the circuit. Metal is what is called a conductor, and we will learn much more about conductors next week. If the electricity does not have a complete path, the light bulb will not light. As long as there is a complete closed circuit, the electricity will move through the wires and the metal and the light bulb will light. All right, so now that you finished watching the video, the next thing you're going to do is click on the words that say Leisha Sherman posted a new assignment, and you're going to open up this Google document just so I can check and see what you guys understand right now. So at the top, you're going to put your name, you're going to put your classroom teacher's name, like Miss Altimer or Mrs. Evans, and then there's 3 questions. Will this circuit light the light bulb? Why or why not? So over here, you're going to type in a complete sentence. This circuit will light because, or this circuit will not light because. Tell me about whether or not it's a closed or open circuit. Tell me if the wires are connected right. Anything that will show me you understand. The second one says, will this light bulb light? And if it still looks like this, you have to actually click up here to start typing. If you try to click on this part of the document, it'll just move you up and you can just type your answer here. It's just continuing on to the second page. And then for the third one was the last challenging one. Will this circuit light the light bulb? Why or why not? So just explain to me what you think is happening with those circuits so I can get an idea of how much you understand right now. On Wednesday, I'll be back with some more fun, cool things about circuits. So I hope you guys enjoyed this lesson and learned a lot about electric circuits.